Anyone? Any questions? Okay. I'm looking now on page 332. Let's look at problem 16. Problem 16, we have a rectangular storage container with an open top. Rectangular storage container with an open top. Is to have a volume of 10 cubic meters. The length of its base is twice the width. The length of its base is twice the width. So y equals 2x, and the width is x. This is the width, and it's twice the width. Material for the base costs $10 per square meter. So for the base, $10 per square meter. Material for the sides. For the sides, they say $6 per square meter. Find the cost of materials for the cheapest such container. Minimum cost. Find the cost of materials for the cheapest such container. In order to minimize the cost, we have to create the cost function. Should we read the problem one more time? Do we need to read the problem one more time? Okay, I'm not sure. No one answered. So a rectangular storage container with an open top, so there is no cost for the top, is to have a volume of 10 cubic meters. The length of its base is twice the width. The length of the base is twice the width. Material for the base is costing us $10 per square meter, and for all the sides, $6 per square meter. And we want to find the cost of materials for the cheapest such container. Okay, so then we know that the cost would be, first of all, the area of the base, which is x times 2x, multiplied by $10 per square meter, and plus the area of the lateral area, I should say, which is unknown height. So twice x times height, and twice 2x times height. Times the cost per square meter. So one more time, I have the area of the base, x times 2x, multiplied by the cost per square meter, and plus two sides that are x times h, 2x times h, and two sides that are 2x times h, and 2 outside. I notice that this function, cost function, has two variables in it. It has x and h, but I do have an additional piece of information that is extremely helpful, because I know that the volume of this container is area of the base multiplied by the height. If that's the case, then the volume, which is 10, must equal area of the base, which is 2x squared. It's x times 2x squared, multiplied by the height. And I can easily remove the height, replacing it with 10 over 2x squared. And in fact, with 5 over x squared. And I'm going to replace it here. And here, of course. So I will determine then a function, which is the cost function, which now it becomes a function of x only. I will simplify this and write 20x squared. I will simplify here and I'll write 12 in front. And then x plus 2x is 3x. And also multiplied by h, which is 5 over x squared. So I pulled out h. So I have 12, and x plus 2x is 3x. But h has to be replaced by 5 over x squared. Does anyone follow? Is anyone okay? Everyone okay? Any questions here? Anything? Okay, well, we are going to differentiate and get 40x plus. I will simplify first. And let me write it one more time. And this is 60 times 3, isn't it? 180. So 180 over x, which becomes negative 180 over x squared. Let me make sure that this is indeed, so 5, so 60 times 3 is 180. I simplify an x, so I have 180 over x, and when I differentiate, I get that, correct. So therefore, I'll continue with one more step. So 40x. Yes, please, please, please.
Where did the negative come from?
When I differentiate 1 over x, we get negative 1 over x squared.
Oh, right, okay. Thank you.
I'm so sorry. My apologies. I should have not written it like that. So if you want me to write it one more time, I should. I will.
No, that's fine.
So when you multiply 5 by 12, it's 60 times 3 is 180, but you simplify 1x with 1x. So you end up here, all this piece is 180 over x. And when we differentiate 180 over x, we get negative 180 over x squared.
Okay, that makes sense.
Yeah, this is one of those things that I formulas. It's not a formula per se, but if you remember a long time ago, I said it would be useful if we can remember this, but I don't want you to just sit there and memorize it. Is that better?
Yes, thank you.
Thank you. So then the least common denominator is x squared, and then I have to multiply by x squared, so 40x cubed minus 180. So let's just go back for a second and make sure that we understand what we've been doing. First, we created a figure. We put in all the information that was given to us. The fact that the length of the base is twice the width. The fact that the volume is given to us. The height is unknown, and the sides, all of them, cost $6 per square meter, but the base costs more, which is 10. So the area of the base, x times 2x times, because that's the cost, times the cost per square meter, plus twice 2x times h and twice x times h, and multiplied by the cost, because that's the cost function. And then I realized that I had to get rid of h. And how can I get rid of h? By simply using 10 as the volume, from the volume. So we wrote that 10 is the area of the base, x times 2x, which is 2x squared, multiplied by the height. And from here we solved for the height, and we got this. And then we multiplied 2 times 10, so it's 20x squared, plus I have a 12 that I put it out in front, and when you combine these, you have 3xh. So I have 3x, and h, I replace it by 5 over x squared. So then, again, this is 180 divided by x, because I simplify an x. When I differentiate this, I get this. When I differentiate this, I get this. And now, I simplified it to the max that I possibly could, because now I have to find critical numbers. So we know that critical numbers come from two sources, from c prime being undefined, but that's not the case, because where the function is undefined, so is the derivative. So the other possibility is this, where only the numerator can be 0. A fraction is 0, only the numerator is 0. So then 40x cubed minus 180 equals 0. And then I am going to write x cubed equals 180 over 40. So I'll simplify and I have 9/2. And then, of course, I have to apply the cube root to both sides. So then x equals the cube root of 9/2. I have no idea what this means, in the sense that I haven't convinced you what it gives. So of course, it's not possible infinity, but I just wrote, and that's the cube root of 9/2, and this is 0. So I look at the derivative. This is always positive. I'm not going to put in anything in there. And when I plug in 0, not in the denominator, but in the numerator, I get negative. This is the cube root of 4.5, so it's not more than 1 and a little bit. So I'm going to plug in 10, let's say. When I plug in 10, this is 1,000, or will definitely overtake this, so this is positive. All I needed to show is that this gives a minimum. And what is our conclusion? Our conclusion is that as long as the width is the cube root of 9/2 and the length is twice as much, and now I'm ready to find the height as well. 5. The height is 5 over x squared. 5 over the cube root of 9/2 squared. These guarantee a minimum cost. If we deviate from x, then the rest will change and we will not get a minimum cost. If we are asked, I don't think we are, but if we are asked to determine the minimum cost, we will plug it in. We will plug in x in the cost function. C of the cube root of 9/2, that will be 20 times the cube root of 9/2 squared, and plus 180 over the cube root of 9/2. And of course, I can determine this with the calculator. If I know where I put it, I found it. So 20 plus, no, it's multiplied, in parentheses, 4.5 to power 2 over 3. And then outside plus 180 divided by, in parentheses, 4.5 to power 1/3. $163.54 for the entire container, given the conditions that we were, the restrictions, conditions that we found in the problem. Any questions? I don't know if you find related rates more fun than this, or you find this more fun. I hope. Okay, so let's look at 43. 43 on page 333. If a resistor of R ohms is connected across a battery of E volts with internal resistance R, lowercase r ohms, then the power in watts in the external resistor is this. If E and R are fixed, but R varies, what is the maximum value of the power? Okay. So let's take a look. So this is any questions on this? Anyone? Anyone? Questions? Okay. We are looking at 43 on page 333. Yes. Okay. So we are given R in ohms. We are given E in volts. We are given lowercase r, also in ohms. Then the power, P, is in watts, is given by P equals E squared R divided by R plus R, everything squared. If E and R are fixed, so what E and R are given as constants. And R varies. What is the maximum value of the power? So basically what we are really told here, we are told that this is a function of R and they are asking us to find the maximum power. This is a nice situation because we are given the function. We don't have to create the function like we did in the previous cases. I got a sip of water. Okay, so obviously in order to find P prime, I have to differentiate. The variable is here and here, so then I have to use the quotient rule, keeping in mind that this is a constant and this is a constant. Since this is a factor of R, I am not going to mess with it. It can wait patiently outside. So E squared is outside. The first function prime is 1 times the denominator minus the top times the denominator prime. 2 times R plus R times the variable prime, which is 1, or times R plus R prime, which is 1, divided by R plus R to the 4th power. Do not be tempted. You have to factor out R plus R before you simplify. So therefore, I have E squared, R plus R outside, R plus R minus 2R divided by R plus R to the 4th power. I'll simplify by one of those. And then now I have E squared and a negative R plus R over R plus R to the 3rd. Like before, I have to find critical numbers. R plus R cannot be 0 because if this quantity is 0, then the power is undefined. So no critical number coming from P prime being undefined. But from P prime of R equals 0, I get the negative R plus R equals 0. So what can happen here is only then when R equals little r. But I don't know if this gives a max or a min. I have no idea. So R is the variable in the problem. P prime of R, I'm studying the sign of the derivative to identify whether this gives a max or a min. So 0 to infinity, of course, not 0 and not infinity, but you know what I mean. So what happens when I plug in the derivative? This is our derivative. We are studying the sign. When I plug in 0 for R, this is 0, this is 0. So I have R over R cubed, which will be 1 over R squared with E squared. So this is definitely positive. Now on this side, I'm going to put, let's say, 2R, because definitely 2R is more than R. So then I have e squared. Then negative 2r plus r will be negative r. And the denominator, I have 2r plus r will be 3r cubed. So this is definitely, all this is positive. This is definitely a negative number. So this is guaranteed to be a maximum. So the maximum power, max power, is when r equals little r. So now P of little r would be e squared little r over r plus r, which is 2r squared. And we can determine this further. So we have e squared r over 4r squared. And I simplify. And that's a simplified form. And this is in what? What? This is the maximum power is obtained when uppercase r equals lowercase